Arithmetic and Geometric Series by Olivia Stringham and Anna Pinnock. Okay, what is the difference between a sequence and a series? Okay, so sequence is a set of numbers, for instance, like 5, 10, 15, 20, 25, with a repeating pattern. And the series is that sequence being added together, so like 5 plus 10 plus 15 plus 20 plus 25. So these are being switched out for these. So you add them together instead of just having a set. Okay, now first we're going to learn about arithmetic series. And the equation for that is Sn, which is the system of terms, equals n over 2, which n equals the number of terms, in parentheses, times parentheses, the first term plus the last term. And we're going to use that to find different values. Okay, so in order to find the 50th term, you plug in 50 into this equation, like so. Okay, so you plug this in, and that equals negative 148. And so in order to find the series, all including 50th term, you go back to the equation from before. Okay, so you also need the first term for this series, so we're just going to calculate the first term as well. Okay, and then that equals negative 1. Sorry, yeah, negative 1. And then you plug that down here for the first term, and then you plus. Okay, so right down here you're going to add the first term plus the last term. The last term is negative 148, and that's negative 149 times. Okay, and then that equals negative 3,725 because you should plug into the terms. Okay, and so the sum of the whole equation to 50 is going to be this. Just like we found earlier. But in order to find this, you have to find the 50th term and the first term. So that's like the last term, and this is the first term. Because if you look back at right here, you have to find the last term plus the first term. Okay, so right now we're trying to find the 53rd term in this sequence. And so sometimes it will give you the sequence instead of just finding the first, third, second, and third. So right now I'd already wrote out the sequence, and you can see if you plug in 1 to this equation, you will get 9, and you plug in 2, you will get 3, and then so on down. Okay, and then we're supposed to find the 53rd term, so you're just going to plug the 53 into this. Okay, and then that would equal negative 303. And now that you have the first term and the last term, you can plug it into the equation. Okay, and then you plug it into this equation above, and that would equal. Okay, and then that would equal negative 7,791, and that's the total sum of the 53 terms in a sequence, in a series, not sequence.
Okay, now we're going to do the geometric series. The sum of a geometric series is this equation right here. So the S sub n is the sum of the terms, and the n, we remember, is the number of terms that you're finding. A sub 1 is the first term right here, and r is the common ratio, which we'll show you how to find in the next example.
Okay, if you look over here, it's asking you to find 8 terms. So this is the equation it's giving you, and so you're going to try to plug in, you're trying to find the first 3 terms, just so you can find the common ratio. So we've plugged in 1 over here, and then 1 we got negative 6, and the second time we got negative 12, and the third time up here, sorry, in the corner, we got negative 24. So if you look at the pattern, it's increasing by doubling by 2 every time, so the r would have to equal 2 because it's using it by 2 every single time. So we plug that back into this equation over here, and we have to plug in r and r over here. So 2 would be the r's. Okay, and then if you go back, you have to plug in n right here. So n is the 8, so you plug in 8 into the, okay, so you plug in 8 over here. And then the first term, you just take the first term right here, and then plug that in right there because it's asking for first term times this. And then the whole thing equals negative 6 times negative 255 over 1, which is just 1530 right over here. Okay, so probably memorize this equation because it's important to the rest of how to do geometric series. Great.
Okay, so in this example, sometimes they'll give you the series before, and you have to find the sum and plug it back into the equation. So to find our r in this equation, we know that r equals 1/2 because 10 times 1/2 is 5, and 5 times 1/2 is 2.5. So r equals 1/2 in our equation. So then what you do to find the sum is we know that the first term, you plug the first term in right here in our equation, and then we know that r is 1/2, so you plug 1/2 into both of these spots, and then we know what we're finding with 5 terms. So 5 goes right here, and then you're going to solve that out. Okay, so then when you solve that all out, it's going to equal, if you round it up, and always leave 3 decimal points, but it will be 19.375. And that's the sum of your 5 terms. Okay, so now we're going to do sum of all the terms if it's an infinite series. So your equation that you'll be given is the sum of the infinite series is a sub 1 over 1 minus r. A sub 1 is the first term, and the r is the rate the series is increasing or decreasing right here. So pretty simple.
Okay, and if you look over here, it's going to give you this equation, and so you have to find the first term. So we just plugged in 1 for n over here, and then we got 2/3. So we know that it's going to be 2/3 over something, and then so it's 2/3 over 1 minus, and then we're saying if you look right here, you can tell that this is r because r is the rate it's decreasing or increasing. So this is the rate, so it's 1/3. So you plug that into the equation down below. And as you can see right here, it equals 1. Okay, and you can tell that this is the rate that the equation is decreasing because it's a fraction rather than a whole number. And so if you try to do something by a fraction repeatedly, it's going to get smaller and smaller. So then that over here, yep. Okay, and then sometimes it will give you a series, and you have to find what r equals. And it's quite simple actually. You just look on how much it's decreasing or how much it's increasing over time, and 1 times 1 equals 2/3 is obviously 2/3. So r has to equal 2/3. And then the first term is over here, so it's 1. So it's 1 over 1 minus 2/3, which that equals 3. And that's an infinite sum of this series. Okay, the infinite sum, I don't think we explained that. But the infinite sum is that all the series, like infinitely going on, all of them added up together. Because they go to a certain point, I guess. And thanks for watching, and have a great day. Good luck.